thank you everyone for joining. I'm hoping that you guys will find this valuable. I think you will. If you haven't used 60 gigahertz before, or it's been a long time, the technology has been around a long time, but what Cambium has done with their product is really turned it up a notch. And I think we're going to see today where you might have some new ideas about where you can deploy this and how it can be deployed. So I'm excited to have Bruce show this to you, and we're going to be here for you. Please ask questions. Please raise your hands. This is why we're here. Put them in and we'll get them answered for you. And Bruce, without further ado, please take it away.
All right, great, Matt. Thanks for that, and thank you everybody for joining. Glad to see such a great turnout. There is a lot of interest in 60 gigahertz these days, and we're very excited about this product. It's been in the market for about a year and a half now, so the product has really matured, and we've seen tens of thousands of these radios deployed. So this is absolutely the right time to get involved in 60 gigahertz and see what it can do for your business. So I'm gonna do probably about maybe 30 minutes of presentation. So I'll take you through some use cases, a little bit about the technology, but certainly, as Matt had mentioned, happy to take questions. So to make it a little more interactive, that would be great if you have any questions, and we can do a deep dive into whatever area is of interest. So I will get this moving here with, I'm not going to do a lot of advertisement for overall for Cambium, but I do want to kind of set the context of where does 60 gigahertz fit into our overall portfolio, because Cambium does have this very broad set of solutions, and you can kind of see that on the picture here. Again, I won't go through it in all the detail, but just imagine we can do in the fixed wireless space, which are the left two columns here. Imagine we can connect pretty much point A to point B, whatever the spectrum, whatever the need as far as capacity and availability goes. So we have lots of point-to-point, point-to-multi-point solutions. And then our really a fast-growing area for Cambium as well is the enterprise side, where we have Wi-Fi and switching, and of course our industrial solutions, where we are selling our products into oil and gas, electric utilities, water treatment, those kind of things. So we're going to really focus today on our point-to-multi-point and point-to-point solution focused on 60 gigahertz. So the rest of the session is really going to be a deep dive into where customers and network operators are deploying 60 gigahertz. As important as the radios are, the software that ties all this together is just as important. So you'll see across the bottom there, we have our link planner tool, which many of you, if you've had any experience with Cambium products, you would know and love. Certainly that continues to expand and is now available in a cloud version. So no longer an app that you download into Windows, but a cloud version. So that's moving along nicely. And then CN Heat, which I won't necessarily touch on in the rest of the presentation, but just know that it's very useful and important to have in the context with 60 gigahertz when you're looking to see sort of coverage maps or where can I connect with CN Heat and 60 gig. And then of course, CN Maestro X is the management system that ties this all together. So whether you're using our enterprise products for Wi-Fi, switching, or any of our fixed wireless products, that all ties together into CN Maestro and CN Maestro X. So nice way to kind of weave everything together in what we call this wireless fabric. So that's the pitch on Cambium, but let's do a deep dive into 60 gigahertz. So what we say with 60 gigahertz is it's really a great alternative or complement to delivering multiple gigabits per second. Where you might have considered fiber before, you can now do this with wireless, and you can do it very quickly and cost effectively using this new technology. So we'll talk about, you don't have to necessarily go on a big tower climb or masts. We see customers deploying these in hours to days versus weeks and months waiting for fiber to come available, or waiting for that trenching and all those costs to the hardscape. If you're having to trench through parking lots or trench through neighborhoods that require permits, you can avoid all of that and still deliver multiple gigabits per second. This all uses familiar tools. So you can do layer 2 bridge networks, it's PoE power, it's unlicensed spectrum. So if you are a service provider and you're used to delivering services based on maybe 5 gigahertz or our CBRS products, or some of our point-to-point products, this will be, there's some differences, but it is pretty comfortable as far as how it integrates into your existing networks. And as I mentioned, fiber-like speeds. So whether you're connecting point A to point B across campus, extending to outdoor Wi-Fi, video surveillance system integrators, and CCTV is a great application for this, IoT. And then the other area that we see of a lot of interest in this is temporary events. So I just want to set up for a farmer's market or a concert or an event that I just want to set up, but I need lots of capacity. This deploys very quickly, and certainly you wouldn't have that option with fiber. So I will go into some more use cases and specific case study examples of how this, but this kind of gives you a lay of the land as far as where it's being used. Again, I say think bucket trucks and ladders instead of tower climbs. So some of the things that you have to keep in mind with 60 gigahertz is that while you have very high capacity links, multiple gigabits per second, the links are relatively shorter than what you might be used to in other bands. And they have to have a 100% line of sight. So there's no thought of going through a tree or a branch waving in front of the link. You really want and need 100% visual line of sight from one end to the other. But there are ways that this new technology really mitigates that and helps you deploy large-scale networks that do require line of sight and short links, because we have this capability called distributed networking, and we'll go into that in a bit more detail. And we also see this technology and the solutions, while we see a lot of deployments on the service provider side, the enterprise and campus connectivity is really taken off as well. So, and I don't think I mentioned it on the first slide, but one of the areas that we see it really complement and be suitable in campus environments is that it is a different spectrum. So if you're used to deploying Wi-Fi in these outdoor spaces, or you've got 5 gigahertz links between your buildings, this will not interfere with that because it's a completely separate spectrum and it doesn't propagate very far. So it really allows you to build nice isolated networks that have narrow beam widths and short propagation, and they won't interfere with your existing Wi-Fi network or your existing 5 gigahertz networks. So it really, some of the service providers have been run into constraints on spectrum. This is a whole new piece of nice clean spectrum that you can go after and use to deliver the capacity. So what's changed? Matt mentioned that 60 gigahertz products have been around for a long time, and that's true going back as far as the 2010 and before. There was a technology called 802.11ad, and that was some early generation products. There's still some legacy equipment out there on the market that uses that older standard. But what Cambium has really embraced is this latest generation, which is 802.11ay. So it is a standards based, it's in that 802.11 family, but AY refers to the 60 gigahertz use of that product. So there are standards based chipsets based on the 802.11 AY standard. And in parallel or layered with that is this concept called Teragraph. Now, Teragraph was incubated out of the research wing of Facebook or Meta Connectivity, where they were researching ways to add the next billion people to the internet. And one of the ways that they championed and incubated was the 60 gigahertz Teragraph approach. And they deployed a number of reference proof of concept networks. They deployed the city of San Jose in California. They deployed a carrier in Malaysia called YTL, and kind of worked out the techniques and the technology to make it a really great solution. And we started working with them probably 4 or 5 years ago at this point, and built cnWave leveraging that technology. Subsequently, Meta Connectivity has now So they call it graduation, but they've sort of handed this off to the industry to build commercial grade hardware and commercial grade software around this technology, and that transition has now occurred. So Cambium has complete ownership and access to all of that software and standards-based capabilities, and we continue to now branch off and expand into that area. But some of the things that brings is lots of capacity. You can do more client nodes. You can double the density of these deployments with 811AY versus the AD standard. These are all GPS synced, so I have less self-interference and I can pack more density into a network. The data throughput is higher. You'll see, I think I'll reference later on, but we have in the roadmap the ability to do channel bonding, so you can double the capacity. Today we do about 3.8 gigabits per second in a sector, and we can see higher capacity coming with channel bonding. That's all higher throughput than what you could do with the AD standard. What's just an important, or probably what the most exciting piece of this technology is this high availability, efficiency, and cloud management. That really allows us to do these large geographic area distributed networks using 60 gigahertz. So I can take a number of, I'll show this on the next slide, I believe, but distribution nodes, and I can distribute them around an urban, suburban, or rural area, and that adds both capacity, but it also adds resiliency. And this is very different from what you might have seen with mesh capabilities before. It's why I kind of call it distributed networking, but it is much faster to reconverge. If there's ever an interruption in the network, the system recovers in less than a quarter of a second, and all of the latency of all these hops is a millisecond. So very different than what you might have experienced with meshing products in the past. This is a very modern architecture, all managed with, as I mentioned before, cnMaestro. So the whole thing is made up really of 3 building blocks. We have, you can see on the left there, the V5000, which is a distribution node. This acts as a kind of access point if you're coming from other technologies, and you can build multiple client nodes arrayed around these distribution nodes. And you can see that then we have a couple of different client nodes, long range and mid gain, short range, the 3000 and the 1000 respectively. And these can either be deployed as point-to-point links, or they can be deployed as clients, hanging off of that distribution node. I'll show you how that topology works here on this slide. So I think one of the areas of some confusion around cnWave is that, and 60 gigahertz, is that 60 gigahertz is a very modern architecture. So at its core, it's using IPv6 and it's using layer 3 routing. But Cambium's solution really exposes layer 2 connectivity and IPv4 management. So it's very comfortable to drop it right into your network operations if you're used to seeing layer 2 networking, if you're used to seeing IPv4 management, that's all available in this. And it kind of starts with this simple point-to-point link, point A to point B. I can connect 2 buildings together in, like I said, 3.8 gigabits per second, 1.9 in each direction. So a nice symmetrical link, lots of capacity and unlicensed spectrum. You can also do point to multi-point. So this is, again, kind of a traditional fixed wireless approach. I have one of these V5000s or a DN. I put that on the roof of a building, and then I can put up to 30 of these client nodes off of each DN, 15 per sector, and build out a point-to-multi-point network. And then what we see as far as where this technology really shines is with our distributed mesh capability. Now I take that distribution node and every 150 meters or so, put those around a geographic area, and I can form rings and meshes, different types of topologies to build out a large coverage area. And then off of each one of these DNs, I can add those client nodes to serve the individual homes and businesses or cameras, Wi-Fi access points. So all of these different topologies are built from those same building blocks of the DN and a couple of different kinds of client nodes. So let's talk about how people are deploying these. Like I said, we have tens of thousands of these deployed all over the globe. I'll give you some examples that are a little closer to home here in the U.S. and Canada. This actually is a village of Standard out in Western Canada, in Alberta, and they took a rural community and covered it with gigabit per second capacity, and they deployed this in 3 weeks. So it is really quick to deploy. Imagine what it would take to deploy fiber through an entire village. It would take months and permits and digging and trenching. They had this online in 21 days. So it really is a game changer as far as that goes. You can see on the right-hand picture there, that's straight out of cnMaestro. So it's all managed, and you can see how this was rolled out with the rings, with the resilient meshing capability, and then the client nodes hanging off of it, which are the little, the smaller dots that in green that are hanging off of the main infrastructure there. So a great example of a rural WISP delivering capacity that beats and exceeds the fiber that might be offered as an alternative. On kind of the other end of the spectrum, we have a large carrier type service provider. This is a carrier in Western Canada called Pentanet. They are delivering gigabit per second service across the entire Perth metro area, which is a very large city on the western side of Australia there, you can see in the map. They are leveraging the V5000s on homes, and then they put V3000s and 1000s, but they have built out a plan and a strategy to cover the entire city. And they really started from a standpoint of marketing this to gamers, because they knew that they needed capacity and low latency, and they weren't able to achieve that with their existing technology. And so they moved to this new 60 gigahertz solution, and that is giving them that low latency, and they really can differentiate their service and offer these packages that support gamers. So they offer 250 meg packages, they offer 600 megabits per second packages, and then even up to a gigabit per second packages to these customers across the board. And they're currently rolling this out commercially across the city, and they're doing about 80 DNs a month. And then associated with that, of course, all the client nodes that come with that. So very rapid deployment across the city, so it does scale up. I'll give you some examples of maybe some smaller deployment. Well, no, this is actually a big one as well. This is a city of San Jose. So I mentioned before that Meta Connectivity had done a couple reference networks with some proof of concept hardware. That has subsequently been replaced now with a commercial grade cnWave 60 gig solution. So if you were to travel to downtown San Jose, California, and get on their free Wi-Fi service down through their main commercial shopping dining district, you would be being fed that data across a 60 gig cnWave solution. So it starts kind of where the San Jose Sharks hockey arena is, and it goes up through their shopping areas and then ends up over in the park areas. So really gives them a nice coverage, and they're looking at expanding this now into some other areas of the city, but it provides very reliable high-speed connections for public Wi-Fi. That's been deployed for over a year now, so that's been well proven, along with this one here, which is City of Aurora. This is more of what I would call like a smart city application, or you could even also think of this as a campus deployment. This is where City of Aurora was using some legacy wireless connections that were delivering 50 megabits per second, and they were having some growing pains. It wasn't giving them enough capacity. So they replaced that with a 60 gigahertz gigabit per second connectivity for primarily city services. So this is connecting the different city office buildings together into a resilient mesh architecture. And since they've created this and deployed it, they've discovered they have a lot more capacity than what they really need today. So they're offering things like, this is where I mentioned before, the farmer's market. They offer point of sale credit card processing. They can offer that as they want to build out additional city services into the parks and recreation side. They're now starting to expand and add some city services based on that infrastructure. Not to leave out the industrial side, here's an example of a rail yard. This is a freight rail company, and they deployed V5000s all along this rail yard, and then they've subsequently added client nodes for cameras and Wi-Fi to do surveillance and security applications. But then running right alongside the track, they use this to collect telemetry data, offload lots of data that comes in on the locomotives as they arrive in the yard. They can pull all that data off in a very high capacity way. So this is a nice example. Again, contrasting what it would take to lay fiber in such a industrial environment, it just wouldn't be feasible to dig underneath these tracks and everything. So definitely wireless was the way to go here. Here's another enterprise example. This is a shopping mall out in Southern California in the Orange County area, and they're using 60 gigahertz to deploy initially video surveillance in the parking lots, but we see a lot of interest in doing Wi-Fi so that as that consumer gets out of their car and starts or approaches in their car, they're immediately able to get on the Wi-Fi that's delivered by the shopping mall, and that starts to give you all of your analytics and Wi-Fi capabilities that come along with that. So you kind of get that experience started even as the car is approaching the facility. So we see that kind of application popping up, whether it's a consumer in a shopping area, it could also be a truck approaching a logistics yard or other types of applications where you want to extend that Wi-Fi from the four walls of the building, but out to the edge of your property. Another example here is a multi-dwelling unit. This is a apartment complex out in the Northeast United States here. What we can offer here, and this really kind of complements our Wi-Fi solution, is use 60 gigahertz to connect the buildings together into a nice tight mesh. And then you have the ability to feed indoor Wi-Fi or outdoor Wi-Fi, and then add Wi-Fi to areas like the tennis courts and the pool area, any of the remote parts of the complex, but it all ties back into one network. So I'm managing the whole network from one pane of glass, again, using cnMaestro. So a nice use in an MDU type environment. So I think that's all the case studies. Certainly there's lots more on our website and other information you can gather from the folks at StreetWave as well. But I want to kind of give you a set of case studies and examples of how it's being deployed. You can tell it's pretty broadly used in all different kinds of applications. A little bit more on the product itself. We have introduced our CN Archer solution, which is a smartphone app. This can be used to align point-to-point links. So we're making it easier for the installers to deploy these. This complements how we do some alignment with our PMP products. We now have this available for the 60 gigahertz. And then I want to give you a little bit of a sneak peek or a preview at some products that are coming in the pipeline and pretty soon. So you'll be able to get these starting by around the end of the year. But we will have a new client node. So if you remember earlier on in the slide deck, I referenced the 1000 and the 3000. The 2000 kind of sits in between, both from a price point, but it also delivers more range. So we see service providers really interested in this product because it helps the business case for I can go a little bit further distance on each V5000 that I deploy, and I could do it at a little bit lower price than the V3000. So it fits nicely in that for service providers. For enterprise and Wi-Fi and video applications, it has a PoE output port. That port, both of those input and output ports are 2.5 gigabit PHYs. So you've got more capacity, and now I can deliver the full 2.5 gig Actually, it works out to about 1.8 in each direction with that symmetrical capability. And I can deliver that to that outdoor Wi-Fi access point. So again, pushing lots of capacity to these outdoor Wi-Fi applications. So a sneak peek that's coming. You'll be able to get your hands on those out here by around the end of the year. We're also doing what we call our bridge in a box. This is take the ability to take a point-to-point link, and for somebody who doesn't want to get into all of the complexities of setting up specific settings for wireless, they can simply take two radios out of the box, power them up with the included power supplies, and point them at each other, and then it'll connect. And we have a 2 gigabit version and a 1 gigabit version. The 1 gig based on our V1000 and the 2 gigabit based on our V2000. So that's a nice solution for some enterprise customers. We also see service providers offering this to their more advanced customers. So let's say you have a customer that wants to add capacity out to their barn or to their boat dock. We have customers that will just ship a pair of these to that customer and have them do the install themselves. So it can cut down on that installation cost, and you can add new revenue to that particular customer in kind of that, what we call kind of that prosumer model, where you've got someone who's willing to do the install themselves. You can get them on the air and get that revenue moving faster. A couple of little tidbits here that we do have something called a direct attach copper cable now. This is in many of the applications for 60 gigahertz, we do what we call relay nodes, where you back to back put a V3000 and a 5000 or two V3000s. This cable, it looks minor in the big picture, but it's pretty compelling because it adds a lot more reliability to these back-to-back links, and it gives you much lower cost than buying SFP Plus modules. So you can save money and do these relay nodes much more efficiently and reliably. And the other thing that we're introducing is, as snow is coming, winter is coming, as we say, we are introducing a radome for the V3000 large reflector. This will prevent the snow and ice buildup on these reflectors. This is something that we will have available here before the snow flies. So in the northern half of the U.S. here. And we'd encourage you, if you're deploying the V3000 in a area that gets snow, that we recommend this as a good solution for that. So I'll kind of wrap up here with a summary of how we see 60 gigahertz fitting into the Cambium portfolio, but also what some of the other solutions that are out there on the market. This product is 802.11ay, so it's standards based. It's based on this Terragraph, and it's fully Terragraph certified. So there's 3 layers of Terragraph certification. There's the node level, there's the network level, which is how the different nodes talk to each other, and then there's the management level, as far as how does routing occur and how does different kinds of setups occur across a distributed network. And we're the only supplier that is certified in following that approach across all 3 layers as of today. I mentioned before that while under the hood, this is a very modern infrastructure. So under the hood, it is using IPv6 to do those and layer 3 routing to do that fast recovery of meshing capabilities. And we can support multiple points of presence and very complex large scale networks. And we're leveraging that modern infrastructure. But if you're just looking to deploy a point A to point B type solution, or you want to manage this just like you manage the rest of your network, you can do that with layer 2, and you can manage it with IPv4 management addresses. And in fact, I believe last time I looked, probably 90% of the radios we've deployed and the networks that we've deployed are layer 2 and using IPv4 for management. So if your comfort level is with layer 2 and IPv4, which many of us have used that for years, that is certainly what we see people deploying, but know that you can always move to layer 3 and v6 later. I mentioned about client flexibility. We have the 1K and the 3K, and we're now adding the 2K, the V2000. So that's going to give a nice price performance curve depending on the range, the availability, and what you're looking for. The distributed networking, I mentioned the specs before, but here they are again. Less than 1 millisecond latency per hop and 250 millisecond recovery reconvergence time on the mesh. So if your history is with 5 gigahertz meshing and some of the products that are out there, you'll be pretty happy that this is a very different approach to meshing. And there's some things that are in the technology that help with that. I mean, it's TDD, it is symmetrical links, it's all GPS synced, and it is again high capacity, so you have that capacity to work with. And then the other thing that you have working in your favor for meshing with this platform is it is the spectrum itself, and the physics of 60 gigahertz is such that the beam widths are very narrow and the range and propagation is relatively low. So you don't have sort of the self-interference issues that you had with previous attempts to do meshing. So this is really a nice way to do that. I talked about some of the tools. We have our CN Archer for alignment, but just as important is all the other tools for planning. As usual, we recommend you start with Link Planner. Link Planner will give you the indication of what kind of range, what kind of capacity that you'll get, and what kind of availability you'll get. So you can do all those trade-offs. Do I want 4 nines availability? Do I want 3 nines? Do I want to go a kilometer or only a couple hundred meters? Link Planner is your friend. It'll tell you all of those trade-offs. For more advanced planning, we do offer a solution called ANP that the team at cnWave or some of our sales engineers and tech support teams can help you with on ANP. And then we also offer CN Heat, which is more of a coverage planning approach, where I can say exactly where can I deploy this radio, even down to what corner of the rooftop I should deploy this in to get the best signal. So I encourage you to take a look at CN Heat as well. And then finally, CN Maestro is what ties all of this together in a network management solution. So that is the somewhat rapid run through of 60 gigahertz. And I'll see if there's any questions that have come in during the conversation.
Yeah, Bruce, we got a few here. So let's go through that. So someone wants to know, it would be great to get a primer on how the licensing works with Cambium. For example, what are the costs that there might be that are above the hardware purchase?
Okay, so good question. And you can deploy a cnWave network with no licenses. So that's the baseline. Is there's no licenses associated with operating the network. You can run CN Maestro Essentials, and you can there's this. We didn't get into some of the details, but this E2E controller. There's no license associated with any of that. I do, however, recommend that people look real closely at Maestro X. CN Maestro X is sort of the more feature-rich version of Maestro, and we've been recently adding some nice visualization capabilities and statistics collecting. You can keep longer duration statistics with Maestro X, and it's really not very expensive. I don't. You can look into that Maestro X, but that's really the only license key that's required. Now, we may down the road, channel bonding might have a license key associated with it, but again, that would be down the road. And as of today, that's it's really just a choice whether you want to deploy Maestro X or not. Is any cost above and beyond the hardware. It also comes with a 3-year warranty, so that's included as well. So you can extend an additional 2 years on the warranty if you'd like, but it comes out of the box with a 3-year warranty.
And for those of you who've never used CN Maestro X, you do have the ability to do I think it's a 3-month trial, 90 days. So you could try it and see if it's, if it's worth it, then you can go ahead and do that.
Yep.
Okay, so the next question, which I think we answered a couple slides ago, but can you install the high gain antenna with the feeder down to avoid the snow accumulation of the reflector? But it looks like we have a product coming out for that.
Yeah, so we would recommend the radome. Wouldn't recommend deploying or deploying it upside down. So
Right.
yeah, really the solution will be this radome.
Great. And then another question: what do you do if the network reaches the 30 CN limit? There's only one pop?
So good question. There are many ways to approach that, but I'll give you a couple examples. If you want to stick with just a point to multi-point and not do meshing, you can just add another V5000 to the tower, and now you've got capacity of 60 coming off of that one location. More commonly, though, what I see is that given the distances that we're talking about, you're better off putting a V5000 100 yards away and in a couple of different locations, and now you can form that distributed network, and that gives you both resilience in the mesh. It allows you to drop a second pop. The question referred to the pop term, which is the point of presence. That's where you might have a fiber injection point into the network. So if I find that I have a second fiber injection point, cnWave does a real nice job of distributing that additional capacity across the mesh. And then just as important, having multiple locations where you have V5000s, you get different angles of approach to all the different endpoints you're trying to reach. So remembering that you have to have absolute line of sight. If I have V5000 separated from each other, now I have multiple ways to get to each endpoint from multiple directions.
Yeah, I think that's a great way. Definitely utilize the DNs, right? And
Yeah.
the
Yep.
meshing technology. That's kind of the whole point. Next question is omni or sector widths. For someone that wants to mesh, for the DN needs to see other units. Just wondering how many APs need to be on site to get a full 360-degree coverage.
Yeah, so a nice thing about this is the solution that you see, well, yeah, there's one in the picture here. There's a V5000 that has two sectors in it, and each one covers 140 degrees next to each other. So you have 280 degrees of coverage from each of these V5000s. So, and you can see that's kind of the back of it's up against that building. So you're able to see 280 degrees outward from this V5000. If you wanted to get something directly behind you, you've got a couple options, which in this case, you wouldn't have any value in that because there's a building there. But if you did want to put something behind you, you could put another V5000, or what we see more customers doing in just about all cases is putting another V5000, 100 meters away, and gives you that that directional angle of approach behind this one. So we've done literally thousands of designs, and this approach using the distributed DNs and the 280-degree coverage has provided the connectivity that the customer is looking for in all of those cases. The other benefit you get of this approach is that because it's two sectors and 280-degree coverage, you're able to do what we call N=1 frequency reuse. So I can use the same channel on both of those sectors, and I can use that same channel again on the DN down the road. And I have multiple channels to use, but in many cases I can do a whole network with a single channel. And so that's kind of some of the design philosophy around that V5000.
Great. We have another question in the works here as well. So will the 28 gig version of the cnWave equipment still be in the market besides the 60 version?
28. So absolutely. So those are we kind of use the cnWave as the sort of umbrella brand around millimeter wave solutions. So 28 gigahertz is a licensed spectrum solution. We're just launching that now, and so to use 28 gigahertz, you need to have licensed access to that spectrum. And there are some operators in North America that have access to that, and I encourage you to take a look at it. So it's quite a bit different technology from 60 gig, and they absolutely coexist. So it's not one or the other. It's really both. When you think about well, if you're a license holder of 28 gig, if you don't have license of 28 gig, then 60 gig, one of its benefits is that it's unlicensed, just like 5 gigahertz, and you can deploy it that way. So Cambium has launched both of these platforms relatively recently, and we see different markets for them.
Okay, so last question here is, what are the plans for releasing a feature to enable speed profiles for CN, such as 500 by 500 or 1 gig by 1 gig?
So I think if I interpret that question correctly, you're looking at a way to do like speed packages, like a gold, silver, bronze type package. So the way I would recommend you look at that today, so we don't support rate limiting in the radios today with 60 gig. So what I'd recommend you take a look at is the QoE solution from Cambium. We call it quality of experience. And that supports rate limiting. And the nice thing about that is the rate limiting would occur out at the edge of your network. It's not done at every individual radio, but it's done at the edge, and it's done by the user and stream. So we support things like rate limiting per application, rate limiting per time of day, per scenario. So I only kick in rate limiting when my network is hitting a certain capacity. So really kind of outside of the scope of this webinar, but QoE is really a nice solution for that. And we will be adding some QoS capabilities to these products most likely in the first half of next year. But if it's something that you want to take advantage of today, then I encourage you to take a look at QoE.
All right, great. That is, I think, all of our questions, and a little selfless plug for the QoE. We will be hosting a QoE webinar in the coming week or so. So watch out for those emails for that. Oh, we got one more question that just popped up. If you've got a second, Bruce.
Absolutely. Yeah.
Do all nodes have a second RJ45 port with PoE? And what can you feed that with that PoE? Up to 25 watts or 60 watts or 90 watts?
Okay, so the different products, so the V5000 and the V3000 have a PoE output port, and those are 1 gig PoE output ports, and they support the AT 25.5 watt standard, so the 802.3 AT. The V1000 does not. It has a single 1 gig physical port. And then the new product, the V2000, what's unique about that is it has both a 2.5 gig PoE in, as well as a 2.5 gig PoE out. And that V2000, the PoE out, is also the AT standard. Keep in mind that if you want to use the PoE output port, you should make sure you select the power supply that delivers 60 watts to the radio, so that you have that extra, sort of power budget to feed the PoE out.
Right. Excellent. So lots of capability there. I think that's all of our questions, Bruce. So
Right.
appreciate your time today and coming out, and for everyone that joined. Hopefully you guys have learned something today, and your interest for cnWave 60 gig has piqued your interest, and we are here and we are ready. We do stock the equipment here at ShrinkWave, so reach out to your sales rep and we'll be happy to get you quoted, and if we need to do design or whatever, we can help with that as well. So
Just throw it, I didn't include it in the deck, but we do offer, and I know that ShrinkWave, you offer that starter kit as well. So if you've never touched the cnWave before, that's a nice way to get your hands on a set of gear that's at a kind of a entry price, and you can start to play with it.
Price. You get a DN and a couple of clients, and yeah, you get to definitely test it out for sure. All right, Angela, do you want to wrap this up for us and
Yep. Thank you. Thanks, Bruce, for the presentation and everyone that attended and all those questions. We will have this recorded and we will share with everybody that attended today, and be on the lookout for it to also be on our cnWave website. So thanks again, everybody, for attending. Have a great one.
Thank you, Bruce. Appreciate it.
All right, thanks everybody. Yep, bye.